Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to be continuing my series on logarithmic and exponential functions. So if you watched the last video, I introduced what logarithms were, a little bit of the basic properties, and how to go about graphing them. So now what I want to do is talk about some laws of logarithms. And these are really just more properties you can get that are a little bit more complex than what we did last time, so that you should have some justification on how to do this. So let's get going. And as always, if you like what you see today, smash the like button, hit subscribe. So the laws of logarithms that we are primarily going to focus on are the following. So the first deals with when you have the product of two numbers inside your logarithm. So it doesn't matter what the base of our logarithm is, so as long as it's positive and not zero. And we need to make sure A, B, C are real numbers with A and B both positive here. Because remember, we can't take the logarithm of 0 or a negative number. This first law, log of A times B. So this is inside our logarithm. That can be thought of as log base A of our capital A plus log base A of capital B. So log of a product can be broken up with addition. Similarly, if I have log base A of A divided by B, I can break this up as log base A of A, so just like above there, but minus, and that didn't look like great minus sign, so minus log base A of B. So I can change division inside my logarithm into subtraction. And 3, log base A of some number A to a power C. I can bring that power of C out in front of it and write this as C times log base A of A. So this is the 3 big laws of logarithms I want to talk about today. And I do want to put in some warnings. As with all of our rules for exponents, logarithms, there's some common mistakes people tend to fall into. So the following are not laws of logarithms. So remember, log base A of A divided by B is not equal to log base A of A divided by log base A of B. I cannot just break up the logarithm with division, so I need to use subtraction. Similarly, I cannot have addition inside my logarithm, so log base A of A plus B. This is not going to be log base A of A plus log base A of B. So these are probably the most common mistakes people make, in that they think that these are log laws and try to use them. They're not. But 1, 2, and 3 up here, these are good laws that you want to use a lot. Now, I'm going to prove them, but I'm going to wait to prove them till the end of the video. So if you don't want to stick around for the proof, you don't have to. But I do want to focus on how can we use these laws of logarithms to make simplifying or evaluating things easier. So let's take a look at some examples. So I have 3 different logarithms we want to evaluate here. Now, one strategy is if you can express any of the values inside of our logarithms as powers of 6, that'd be great and we could do something with it. But as is, I don't really have a nice way to express 3 or 12 as a power of 6. But I can use that first law from up here and take that addition down here and turn it into multiplication inside a log base 6. So I can make this 3 times 12. And when I do that, log base 6 of 3 times 12, I have 36 inside. 36 now can be expressed as a power of 6. And in fact, log base 6, I can have this as 6 squared inside. and log base 6 and a power of 6 effectively cancel or undo each other to leave me with 2. So I can evaluate it. Similarly with b, I can apply the second rule for logarithms. So I can take this subtraction and combine it into one logarithm, since I'm not going to express 80 or 5 as a power of 2. So this can be written as log base 2 of 80 divided by 5, and 80 divided by 5 is 16, so log base 2 is 16. And now you're in luck. 16 can be expressed as a power of 2, so log base 2 of 2 to the 4th, because that's what 16 is, and then the log base 2 and the 2 to the 4th kind of undo each other to leave you with 4, so we can get that. And finally for c here, now I have a number out in front of my logarithm, and I can use this third log. A number out front can be brought inside as a power. So when I go back to this, I can bring in that negative 1/3 inside. And notice since there's no subscript here, we're looking at base 10 logarithm. This is the common logarithm. So I have 8 to the negative 1/3 power, which you may remember from our exponent rules. I can make positive by looking at it as 1 divided by 8 to the 1/3 power. Now, 8 to the 1/3 power is the same way of looking at it as a cube root, and you might remember that the cube root of 8 is 2, and you can think of it that way because 2 times 2 times 2, so 2 times itself 3 times, is going to be 8. So that means that I can just simplify the inside to 1/2, so log of 1/2. And now this one's a little more complicated. I can't do anything because it's a common log, but there's division inside, so I can break it up with that second law again to make this log of 1 minus log of 2. Well, log of 1 is always 0 no matter what the base. So then this becomes 0 minus log of 2, which is equal to negative log of 2. So that's about as simple as I can get. So we can use these new laws of logarithms to go and simplify some of these expressions. Now, usually what you'll do is apply these laws to get it to something a little bit simpler that you can apply your nice properties to from last time. So laws will serve as a purpose for this. The other two types of things you'll usually do with these laws of logarithms is either expand an expression or condense it. And we kind of did a little of both in C here. So let's look at this. When I say expand, we mean break it up as big as possible. So instead of having a 7x inside, I can use that first law to write this as log base 2 of 7 plus log base 2 of x. And then there's not any laws I can use to break this up any further. So what I'd like you to do, try seeing if you can expand b on your own here, because there's a lot of multiplication and powers in here. So give it a shot. Okay, hopefully if you gave it a shot, you did something like the following. You hopefully broke up our logarithm into 3 terms using that first rule. So you took care of the x's, the y's, and the z's in our product, but you didn't deal with the powers yet. Hopefully you dealt with the powers in a second step to get yourself 2 log base 7 of x plus 3 log base 7 of y plus 24 log base 7 of z. And now I always recommend try to not apply too many laws in one step. So I broke it up into 2 distinct steps here. I guarantee you'll help yourself make less mistakes, and your teacher will appreciate it because they'll really be able to see you clearly applying the steps. Now, C is a little more complicated here. So pause this again. See if you can do this. Okay, hopefully you pause it and give it a try. If you did, you probably broke up that division first like the following. So I just broke it up in a basic subtraction. Then, hopefully, you did the following to each term in your next step. you use that first rule to break up the multiplication in each term of our logarithm. But note, I put parentheses around that second term when I broke it up because that negative needs to distribute to the whole thing. And then in the third term, you might have done the following where you distributed your negative, but I also changed that fifth root to a 1/5 power. So you're going to want to be comfortable going back and forth between your exponential form and your root form nowadays. So you want to get comfortable with that. Fifth root is the same as 1/5 power. And then finally, you hopefully took that 1/5 outside of the logarithm by doing the following. Just bringing it out in front of our natural logarithm here. So this is a much bigger expansion. So expanding expressions is one way you can show your teacher how you know the laws of logarithms. The other way you can show your teacher that you know how to use laws of logarithms is by condensing things, so combining expressions. So the opposite of what we just did, we want to make things as compact and neat as possible. So in an example like 3a here, the first thing I might notice is I have these numbers out in front of my logarithms. I might as well bring them inside as powers. So I applied that third law. Once you have that, because we have two common logarithms added together, we can combine them into one logarithm by multiplying what's inside of the logarithms. And finally, if you don't like fractional powers in your final answer like me, I don't like raising things to the 1/2 power, I can take that and turn it into a square root to get log of x to the 4th square root of x cubed plus 1. And this is definitely a lot more condensed than what we started with. Now, you're noticing in all these problems, I'm putting lots of parentheses in, and I encourage you to do that. If you always put parentheses, you're emphasizing what's inside of the logarithm. Sometimes if you're getting a little bit careless and not putting parentheses, you're more likely to make a mistake and forget that something's inside or outside of it. Now, why don't you try pausing this video and giving B a try? Okay, hopefully you paused this video and gave B a try, and if you did, you probably did something like last time where you brought your powers in first. Next, you hopefully dealt with that subtraction out front using our subtraction rule to get the following. And finally, when you have two logarithms of the same base with our addition there like that, you can combine them with multiplication inside. Now, I actually did an additional thing. I said I don't like fractional exponents, so I turned that into a cube root for t, because t to the 1/3 is the same thing as cube root t. But this is, again, another way where we can really condense our logarithms here. Now, I hope this gives you a little bit better idea how to work with the laws of logarithms. And I lied at the beginning of the video saying I'd do the proofs. I'll do the proofs in the next video. So if you found this video useful on how to figure out the laws, our three main laws of logarithms, hit the like button and check out my next video if you want to know the proofs.